All right, so now we got to classify this triangle below by angles and sides. All right, so let's just do sides first. That takes a long time. All right, so I'm going to do one via the distance formula just for review. And then we'll do the other ones by Pythagorean theorem shortcut. So AC, we're going to use the distance formula to find this. And remember, it's x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. All right, and then like I can label points and stuff. I can say, well, that's x1, y1, and remember, it doesn't matter which point's which. All right, it doesn't matter, because since we square it, it all comes out nice, slick, and clean in the end. So I wrote out the distance formula, and I'm going to plug in numbers. X sub 1 is 1, x sub 2 is negative 3, so it's going to be 1 minus negative 3 squared, plus y sub 1 is 4, y sub 2 is 0. All right. Now I'm just going to clean this up a little bit. I'm going to write 1. So we had minus and negative right here. That became a positive squared plus 4 minus 0 squared. Oops. Anywho, now wrote out the distance formula, plugged things in, cleaned it up a little bit. Now it's just a bunch of easy calculations. All right, don't be daunted, don't be scared, don't be terrified. We just have 1 plus 3. Again, we're just doing 1 plus 3, 4 squared. 4 minus 0, 4 squared. All right, 1 plus 3 is 4, squared, 4 minus 0 squared. So again, just make sure we keep our work organized. 4 squared plus 4 squared, I get 16 plus 16, radical 32. And if I want, I can put this as a decimal. Again, I'm really smart, but I don't know radical 32 off the top of my head. I know it's a number less than 6, and it's 5.7-ish. All right. Now, that was the length of AC. Now, let's find the length of BC. And let's do this doing the distance formula shortcut, or the Pythagorean theorem shortcut. All right. So remember, I can just set up a right triangle. And in a unit coming up, in Unit 7, we're going to talk about Pythagorean theorem in great detail. But I have 1, and I have 1, 2, ooh, hold on a second. Never mind. 1, 2, 3, 4, 5, 6, 7. All right. And I'll call this side C. So for this side, I can just say, well, C squared equals 1 squared plus 7 squared. All right, and if you forget the Pythagorean theorem shortcut, I'm writing it right here really fast. C squared equals A squared plus B squared. So C squared equals 1 plus 49. C squared equals 50. All right, then I take the square root of both sides, and C equals the square root of 50, which is going to be a number really close to 7. Square root of 50 is about 7.1. All right, and then just to save time, we're going to do the eyeball test and say, well, we can tell by looking at it that that's going to be a different length than the other two. All right, so furthermore, let me rewrite this. That was length BC, and AB is some different length. I can tell by just looking at it. Just to save time on the video, we won't solve that. All right, those two sides were the ones that might have been the same. So we know it's scalene. All right, so we use the distance formula, Pythagorean theorem shortcut. That's how you find the side lengths. And then what we have to do now is slopes. Slopes. This is phase 2, part 2. So we're looking for perpendicular lines. And what's so great about perpendicular lines? Their slopes are opposite reciprocals. All right, that means you change the sign. So a positive to negative, or negative positive, and reciprocal means you just flip. All right. So for this one, the slope of AC is equal to, we'll just count it, rise over run, 1, 2, 3, 4, 1, 2, 3, 4. So we went up 4 over 4. Up 4 over 4, so that number is also known as 1. And then for the slope of AB, remember rise over run, so down 1, 2, 3 over 1, 2, 3. Slope of AB is down 3 over 3, which is -1. Now, we changed the sign, so that part, check. And when you flip 1, remember every number is technically over 1, we just don't write it. So we still flipped. 1 over 1 flips to 1 over 1. So we changed the sign and we did flip. So that means it's perpendicular lines. That means we have a right angle. That means it's a right scaling triangle.